Hi children, good morning. Welcome to the class and we are discussing about triangular inequalities. Okay, so in the last class we already discussed about few inequalities. So let us continue with the same topic and coming to the next theorem. If two sides of a triangle if two sides of a triangle are are unequal, then the then the greater side has greater side has greater angle opposite to it. So look at this statement, everybody. If two sides of a triangle are unequal, then the greater side has greater angle opposite to it. So for example, let us consider a triangle ABC. So assume that AB and BC are the two unequal sides. Unequal sides. Then clearly here say AC is the greater side. Then what we need to prove that the angle opposite to this one, which is angle B, isn't it? So we need to prove that the greater side has greater angle. So for that write down first of all what is given in a triangle ABC. AC is greater than AB. AC is greater than AB. So do one thing, construction. So mark a point on AC. Suppose say this is a D. Say some D such that AD is equals to AB. So write it that mark a point D on AC such that AB is equals to AD. This length is equals to this length. Then only we can say that AC is definitely greater than AB. So now coming to proof. See, just now we constructed that AB is equals to AD because of construction. Okay, ma. Now what can you say about angle ABD and angle BDA? Angle ABD and angle BDA. I think these two are equal. ABD, this angle, even ADB, this angle. Why? Because these are the two angles opposite to equal sides. Angle BAD, no, this is these two, which are AB. Okay, sorry. AB and AD are equal, no? So yeah, correct. Angle ABD. Because angles opposite to equal sides. So that's why these two are equal. Therefore, can I say that angle BDA, observe properly, is greater than angle DCB, no? Angle BDA, this angle will be greater than DCB, this angle, because clearly this side will be greater than this side, no? Since I can mention that extension of angle ABCD will be greater than each of its internal angles. Okay. Say suppose this is condition number 1 and let it be condition number 2. Understood, ma'am? What next? So using 1 and 2, what I can say, you see, ABD is equals to BDA, but BDA is greater than DCB. So I can say that from 1, 2, angle ABD is greater than angle DCB. So this is relation number 3. Also, can I say that angle ABC is greater than angle ABD? Why? Because, see, why? Because angle ABD is a part of angle ABC, isn't it? Observe the diagram properly. ABD is a part of angle ABC. So definitely angle ABC will be more than angle ABD. Let it be relation number 4. So still what we can say that, therefore I can also say that angle ABC is greater than angle DCB, isn't it? Using third equation, because ABD is already more than this, but whereas more than ABD, ABC is more than angle ABC. So from 3, let it be from relation number 3, I can say that angle ABC is greater than angle DCB. So what I can say finally now, therefore angle ABC is greater than angle ACB. Angle ABC is greater than angle ACB. So thus we can say that AC is greater than AB. That implies angle ABC is greater than angle ACB. Isn't it? So observe the proof properly. The statement is greater side has greater angle opposite to it. So that means according to our diagram, our construction, AC will be the greatest side and its opposite angle is angle B. That's what angle ABC. So we need to prove that angle ABC is the more than, greater than all other interior angles. Okay? So very simple. Look at that. So look at the converse of the previous theorem. If two angles of a triangle are unequal, earlier two sides of a triangle are unequal, now the converse, no? If two angles of a triangle are unequal, then the greater angle has greater side opposite to it. So now greater angle has greater side opposite to it. Fine. So let us assume a triangle ABC such a manner that angle ABC will be greater than angle ACB. Isn't it? Fine. What we need to prove? RTP. So angle ABC, I mean opposite to angle B, the side is nothing but AC. We have to prove that AC is greater than AB, no? Because angle ACB, this angle opposite side is AB. So we need to prove that AC greater than AB. So look at this interesting proof. Coming to proof, so here we may have three possibilities. We may have three possibilities only. What are they? Either say AC is equals to AB, or second one, AC may be less than AB, isn't it? And third one, AC can be greater than AB. So when you compare with two sides, then those two sides, the relationship between those two can be like this. Either both are equal, or one is less than the other one, or the other one is more than the second one. Isn't it? So let us see, for example, case 1. Is it correct or not? What is case 1? AC is equals to AB. So what happens if it is AC is equals to AB? Then in this case, say sides are equal. That means just now we proved, no? So equal sides having equal opposite angles. So that means I can say that ABC, AC opposite angle will be angle ABC is equals to angle ACB. Is it no? Just now we proved angles opposite to equal sides are also equal. So not like that now. Here according to statement this angle should be more than. So therefore what I can say that AC is equals to AB is not true. Next, coming to case 2, AC is less than AB. Let us see whether is it true. If AC is less than AB, I mean that implies I can say, can I write it AB is greater than AC? No, both are same. No, AB is greater than AC. So AB side opposite angle is what? Angle ACB greater than AC opposite angle, which is angle ABC. Just now we proved greater side has, why? Because of greater side has greater angle. Opposite to it. But this is a contradictionary. This contradict to what is given. What is given? So let us write that this is a contradiction to what is given. To this contradicting the, which is against to the given statement. Therefore, what we can say that, therefore, AC is less than AB is not true, isn't it? So, first condition is not true, even second condition is also not true. So, we left only one condition. Thus, we can say that AC is greater than AB. Definitely first two are not true, no? Hence I can say that third one is the correct statement. That is AC is greater than AB. Therefore, we can mention that angle ABC is greater than angle ACB. Isn't it? So, that's what I can say that because of greater angle, then opposite sides are also greater angle has greater side opposite to it. Understood? Very simple. Just look at the three conditions. Look at the statement of next theorem. Next theorem. See, of all the line segments that can be drawn to a given straight line from a given point outside it, then the perpendicular is the shortest one. Okay? See, for example, let it be a line segment AB. Say some P is a point outside to it. Now draw the perpendicular from P to this line AB. say that suppose it meets at M. Assume that N be any other point on the same line segment AB. Now also join this PN. Now see, M and N are both are the points on the same line. Now according to this concept, we need to prove that the perpendicular one is the shortest. I mean PM is less than Pn. That's what we have to prove it here. Okay. So write it first of all. What is given? A straight line AB. A straight line AB and P be a point outside. P be a point outside to it. Outside to it. Okay. Right. Construction. Draw PM perpendicular to AB. PM perpendicular to AB. Okay. And here itself you can add that M comma N are 2 points. Just 2 points on line segment AB bar. Okay. So what we need to prove or required to prove? Have to prove that PM is less than Pn. Fine. So very simple. So look at the proof. Coming to proof, what is the angle PMN? Clearly perpendicular, no? 90 degrees. 90 degrees. Because PM is perpendicular to AB. Fine. And what can you say about angle PNM? PNM, this angle. Sure, we can say that less than 90 degrees. Less than 90 degrees. Hence, see, hence I can say that angle PMN, or do one thing, angle PNM will be less than angle PMN. Can I say it or not? From the above one. So just now we discussed greater side having greater angle opposite to it, as well as greater angle having greater sides opposite to it. So according to that, see PNM, this is the angle, no? Its opposite side is PM. I can say that PM is less than angle PMN. Angle PMN, opposite side will be PN, no? PM. So this is what we need to prove, that PM is less than PN. Okay, children. So among all these line segments, the perpendicular one is the shortest. So not only that, still you can assume any other points also. Let it be one more point. You can join them. Okay. There also you can observe that among all these line segments, the perpendicular one is the shortest. Coming to the next theorem. show that the sum of three altitudes, the sum of three altitudes of a triangle is less than the sum of the three sides of a triangle. Okay, so look at the statement. Sum of three altitudes of a triangle is less than the sum of three sides of a triangle. So to prove this statement, consider a triangle ABC, and coming to altitudes. You know, altitude is nothing but a line, perpendicular line drawn from vertex to opposite side. Perpendicular line, let it be the perpendicular line drawn from vertex A to opposite side, which is BC. In the same manner, draw the perpendicular from vertex B as well as perpendicular from vertex C. Assume that they meet at D, E, F. Okay, ma. So altitudes are nothing but perpendiculars. So first write down what is given. What is given? In a triangle ABC, AD, comma, BE and CF are the altitudes. Okay, altitudes. Fine. What we need to prove, required to prove, sum of the three altitudes. AD is one of the altitude, BE is one more, and CF is one more. So sum of these altitudes is less than the sum of the three sides. I mean AB plus BC plus CA. Isn't it? Okay. So now coming to proof. Observe this small triangle ABD. In triangle ABD, what can we say? Angle ADB is equals to 90 degrees, no? Angle at D, ADB, which is 90 degrees, which is given already because of their altitudes. Now what about the rest of the two angles? I mean angle ABD, clearly less than 90. Even angle ABD is anyhow less than 90, no? So what I can say that therefore angle ADB, which is 90, whereas this is less than 90, hence ADB is greater than angle ABD. Can we write it or not? Isn't it, man? Because this is exactly 90 degrees, whereas this angle is less than 90. When you compare these two, then ADB is greater than ABD. So just now we proved, no? Greater angles have greater sides opposite to it. So ADB, for this angle the opposite side is nothing but AB. I can say that AB is greater than angle ABD. I think AD, no? Isn't it? AD. Why? Because side opposite to greater angle. Isn't it? Fine. Is greatest, you can say, or is longer also, because of side, no, length, no. So longer we can say. So in the same manner, similarly, see, we tried with angle ABD, no? Rest of the angles. Using that, we can prove that BC is greater than BE as well as AC or CA. AC is greater than CF. Okay. So now, using all these relations, say suppose this is relation 1, let it be 2, and now let it be 3. So from 1, 2, 3, what we can say that clearly, if you add all left side parts, AB plus BC plus CA or AC, anything, no problem, is greater than BE. Before that AD, no, first one AD. So greater than AD plus BE plus CF. So this is what I can say that, therefore AD plus BE plus CF is less than AB plus BC plus CA. I mean, in a triangle, sum of the altitudes is less than the sum of the three sides. So look at this question. In the given figure, AD is a median of triangle ABC. Then prove that AB plus AC is greater than 2AD. So median. What is meant by median? What is meant by median? The line joining of vertex to the midpoint of opposite side. I mean, here D is the midpoint of BC. So this part is equals to this part. So AD is the median. Now we need to prove that AB plus AC is greater than twice of the median length AD. Isn't it? So what to do? First of all, write given condition, given that in triangle ABC, AD is a median. Okay, AD is a median. Fine. And what we need to prove? Very clear, the condition is AB plus AC is greater than 2 into AD. So look at the construction part here, what to do. what to do? So do one thing, produce this AD to some extent E, such a way that AD is equals to DE, and also you join BE. Okay, so write it. What is the construction? Produce AD to capital E such that AD is equals to DE. Okay, also join B. Fine. Now coming to proof. See, we want to prove that intention is look at these two triangles. What are they in triangle? ADC as well as triangle BD or EDB, anything, EDB or BDE. So can we prove them they are congruent? No? Are they congruent? So in this, see what we have in these two triangles. One is ADC. This is the triangle ADC, and this is the another triangle. Now my intention to prove these two are congruent or not. Okay, fine. First one, what I can say, DC is equals to BD. DC is equals to BD. Why? Because since AD is median, AD is a median. And what we have, once again, we have one more condition that AD is equals to DE. Just we constructed in such a manner construction. By the construction, we can say that these two are equal. And now, what can you say about angle ADC and angle EDB? ADC and EDB, these two angles, they are vertically opposite angles, no? That's why they are equal. Vertically opposite angles, hence they are equal. So side angle. So by SAS congruency, I can say that triangle ADC is congruent to triangle EDB, isn't it? Why? By SAS congruency. Right, children? Now, since these two triangles are congruent, then their corresponding parts BE, which is equals to AC. BE is equals to AC because of CPCT, corresponding parts of congruent triangles. Okay. Now also observe the triangle ABE. In triangle ABE, look at this triangle ABE. What we can say? Clearly, we know that sum of any two sides will be greater than third side. So hence I can say that AB plus BE is greater than AE, we can write it. Isn't it? So now AB plus BE is greater than AE means what we can say? AD plus DE we can say. Isn't it? Now AB plus BE means, can I write it AC? No? AC which is greater than. See, just now we proved AD and DE are both are equal here. So hence AD, even in the place of DE also I can write it AD. Now AD plus AD, which is 2 into AD. So I think this is the condition what we need to prove. AB plus AC is greater than 2 into AD. Okay. Thank you.